This section will begin our study on systems of equations, and you've probably talked in your algebra class, pre-calc algebra class already about how to solve by substitution and elimination. We're going to look at modeling systems of equations. So at a college bookstore, Carla purchased a math textbook and a novel that cost a total of $54, not including tax. If the price of the math textbook is 8 more than 3 times the price of the novel, write and solve a system of linear equations to determine the price of each book. Now, over on your notes, it will use X and Y. I want you to define X and Y. I like to use a letter that I can keep up with, like M for the math textbook and N for the novel. So we know if we take the cost of the math textbook and add to it the cost of the novel, we'll get a total of $54. And then we're also told this situation. The price of the math textbook is 8 more than 3 times the price of the novel. 3 times the price of the novel plus 8. And now we can just use substitution in this situation and plug in. So I'm just going to plug in 3n plus 8 for m here. And 3n plus n is 4n. Subtract 8 from both sides. And divide by 4. So the cost of the novel was $11.50. Then to find the cost of the math textbook, we'll just plug in the cost of the novel for n. And we get that the textbook was $42.50. The next problem we'll look at, it says Anne invested $12,000 in 2 bank accounts. One of the accounts pays 6% annual interest, and the other account pays 5% annual interest. If the combined interest in both accounts after a year was $700, how much money was invested in each account? So we have the first account, and this one I am going to call X and Y. And the second account, well, let's do this. F for first and S for second. Adding them together, we would get a total of $12,000. So the next equation will deal with our interest. The first account is 6% interest, so 0.06 times F. And the second account pays 5% interest, 0.05 times S. And that interest by the end of the year is worth $700. Now we have our 2 equations we can solve. I would solve this by elimination. I'm going to multiply the first one. Let's get rid of the F's. So we would need, we've got 0.06F, so we need negative 0.06F on top. So we'll have negative 0.06F minus 0.06S equals, don't forget to multiply the 12,000 by negative 0.062 also, so negative 720. And then we add. So the F's go away, and we'll have negative 0.01s equals negative 20. Divide both sides by negative 0.01 and you get $2,000. So Anne invested $2,000 in the second account. How much did she invest in the first? Well, just go back and plug in probably to the first equation. That'll be the easiest. Subtract 2,000 from both sides, and she invested $10,000 in the first account. When you're doing these, make sure you tell me which one is which. If you just say 2,000 and 10,000, for one thing, you didn't tell me the units, dollars, put your dollar signs on there. And for another thing, I don't know which one you think's the 2,000 and which one's the 10. You have to tell me. So $2,000 in the second account, $10,000 in the first account. Be careful to tell me which one is which. Otherwise, I can't give you credit. Then this problem says a boat can travel 16 miles upriver in 2 hours. The same boat can travel 36 miles downstream in 3 hours. What is the speed of the boat in still water? And what is the speed of the current? I remember another teacher telling me she called these motion sickness problems, and I get it. They're not the most fun to figure out, and they're obviously motion. So the way you want to work these is first by setting up a table with rate, time, and distance. Okay? Because we know that little formula that says that distance is equal to rate times time, right? So when you're figuring this out, it says the boat can travel 16 miles upriver in 2 hours. So upriver, it's going against the current. Let's set some definitions here. S is going to be the speed of the water, or speed in still water. And C will be the speed of the current. Okay. So if you're going upstream, you're going against the current. So you're subtracting C because you're going against it. And the time was 2 hours and the distance was 16. Then it says the same boat can travel 36 miles downstream in 3 hours. Now downstream, you're working with the current, S plus C. Okay? So if we have distance equals rate times time, then you've got rate times time equals distance. And rate times time equals distance. Now we can distribute. So this would end up giving us 2S plus 2C equals 16. And 3S plus 3C, and that was supposed to be a minus up there, minus 2C equals 16. And 3S plus 3C equals 36. And I'm going to use elimination getting rid of the c's. So negative 2 and 3, we could get them to be negative 6 and 6. So multiply the top one by 3, multiply the bottom one by 2. So we'll have 6x minus 6c equals 48, and 6s plus 6c equals 72. Now we can add, and our c's will go away. So we have 12s equals 120. Divide both sides by 12. And we get 10 miles per hour. Now tell me which one is which. So 10 miles per hour, S was the speed in still water. So 10 miles per hour in still water. Don't have to write a complete sentence, but make sure it's clear to me. And then we can plug into either of the above equations. So I'm just going to plug into the first one. So 2 times 10 minus 2c equals 16. Subtract 20 from both sides. Divide those sides by negative 2. And the speed of the current is 2 miles per hour. Okay, so there's several examples of modeling with systems of equations.